Guys, so we're starting the day 2 video today, and last week we ended by talking about monoatomic anions and monoatomic cations. So we talked about how to name them. So a monoatomic cation basically has the exact same name as its uncharged family member. So a lithium atom, a lithium ion is the same thing as a lithium atom. They're both just called lithium. While when we're talking about monoatomic anions, they change their name. So a fluorine will become a fluoride after it becomes charged, after it gains an electron and becomes charged, right? So today we're going to be talking a little bit about binary ionic compounds. As you guys can tell from the prefix, bi means two or different, right? So a binary ionic compound is a compound that is not made of two of the same. It's made up of two different compounds that are put together, right? So for example, when I look at magnesium bromide, I can see that my compound has one magnesium and two bromides in it, right? So as you know from what we said yesterday, the charges have to always be equaled out. So my magnesium has a charge of +2. You can figure this out by looking at the periodic table that was presented above. And to balance that out, you need two bromides that are negatively charged so that overall your charge is 0, because +2 and -2 equals to 0. Okay, so now let's talk about naming binary ionic compounds. As I said, there are two different atoms going on here, so your name is going to be a combination of both of those names. This is actually a very simple thing. It's not overcomplicated. Remember, aluminum is your cation, and its name does not change because cations' names don't change. So aluminum is just aluminum. And then the name of your anion comes next. It's going to be oxide. Just like how before we said that when we have an atom turn into an anion, we drop the end of its name and we add "ide" at the end. So this used to be oxygen, it's now oxide. And the overall compound is just aluminum oxide. Aluminum is the name of the cation and oxide is the name of the anion. Very, very simple. We don't have to mention anything about numbers in the name. There are going to be situations where you have compounds where you do have to mention the numbers of the atoms in your compound, but luckily when it comes to ionic compounds, they keep it simple. The name of the cation and then the name of the anion. All right. Remember, the cation always comes first, okay? And then the name of the anion comes. So that's just a rule to follow. All right, so now let's go ahead and try to figure this out. I have an aluminum and I have an oxygen. Obviously, you guys know where this is going because we were literally just looking at it. But let's go through the question as if we don't know. All right, so first things first, I want to find out how many aluminums and how many oxygens are going to be in my overall compound. I need to know how to balance them out and how to make this work for me. So the first thing I'm going to do is I'm going to go to my periodic table and I'm going to look for aluminum. Aluminum is right here, so it has a charge of +3. And oxygen is right here. It has a charge of -2, right? So I'm going to come here and I'm going to draw aluminum Al with a +3 and oxygen with a -2, right? And now, to figure out how many aluminums I need in my compound and how many oxygens I need to balance this whole thing out, you can do this really cool trick called crossing over, or swap and drop. So I'm going to take my aluminum and my oxygen, and I'm going to swap this. I'm going to take the 2 down here and the 3 down here, okay? Sorry. All right, so I'm going to end up with aluminum, 2 aluminum atoms, each one has a +3 charge, and 3 oxygen atoms, and each one has a -2 charge. Remember, the charges have not changed. The only thing that we were achieving by doing this crossover is finding out how many atoms of aluminum I have and how many atoms of oxygen I have, okay? So basically, when I'm writing the overall compound, I don't actually have to write the charges. So it's just going to look like this: aluminum oxide. Okay? I'm going to name this obviously because I have one aluminum atom, which is my cation, and one oxygen atom, which is my anion, and you know oxygen gets turned into oxide once it loses electrons. All right, so now I want to double check my work. I want to make sure that I have actually balanced out my equation and that this is actually making sense, right? So the first thing I'm going to do is I'm going to find the overall charges on aluminum. So I know that there are 2 aluminums now, not just one. And I know that each one of them has a charge of +3. Okay? So this is for aluminum. There's 2 of them, and each one has a charge of +3. And then I have my oxygen. I have 3 oxygens, and each one of them has a charge of -1. So it's 3 times -2. Sorry, I meant -2. Okay? So now I can find the overall charge of all of my oxygens and the overall charge of all my aluminums. And it'll end up being +6 -6. So my overall charge of aluminums is +6, and my overall charge of oxygens is -6. +6 and -6 is equal to 0. So I now know that this compound is perfectly balanced. I've named it, and all the charges cancel out and equal up to 0, so this must be correct, right? Remember, we always put a box around our answer to make sure that the teacher knows that this is the answer, that this is the final thing, all right? All right, let's try another example of zinc and chlorine. So first thing we need to do is we need to find out what charge is on zinc and what charge is on chlorine. The way we can do that is to go to the periodic table. So I can see chlorine is found right here in the halogens. So it has a charge of -1. Very obvious, it's in the right row. Now let's find zinc. Zinc is right here. Now he's not in any of the rows that we know about. So what we can do, this periodic table has this extra little bit of information. This is why I sent you guys this one. You can zoom in, and on the top right corner, it'll tell you what charge this atom will have when it turns into an ion. So zinc will have a charge of +2, and chlorine will have a charge of -1. So let's go ahead and write that. Zn +2 for zinc, and chlorine -1. All right, so let's do our thing, the swap and drop. There we go. So now I know that I have 1 zinc atom and I have 2 chlorine atoms, right? Makes sense. Which means that this is going to actually end up looking like this, ZnCl2. Remember, whenever there's a 1, we don't represent the 1. We just pretend it doesn't exist. And I'm going to go ahead and I'm going to name this by its names. I know that zinc is just going to be called zinc, and chlorine, the INE is going to be dropped, so I'm going to get rid of this, and I'm going to write it as chloride. So this is the name of my overall compound, and this is the actual compound. Now, I can say with very high certainty that this is correct, but let's double check anyways. All right, so first thing, I'm going to find for zinc has +2 and 1, so it's 1 atom times +2 charge, and then my chlorine, there are 2 of them and each one has a negative charge, 2 times -1. Overall here we have a charge of +2, overall here we have a charge of -2, which means that overall +2 and -2 equals 0. So yes, this is most likely correct because its charges are balanced and everything has worked out properly, right? Let's try another question. Zinc and sulfur. So I already know that zinc has a charge of +2. Let's go and find sulfur. Where is sulfur? Sulfur is right here, so it has a charge of -2, right? So I'm going to go here. Sulfur has a charge of -2. It already looks perfectly balanced to me, right? Zinc +2, sulfur -2, swap and drop. So now I have a zinc with a +2 charge and 2 zincs, and a sulfur with a -2 charge, and I have 2 sulfurs. So it should look like this, Zn2S2. However, this is actually not entirely correct. This is because when you have two numbers that are exactly the same, you can just divide them each by 2 and get rid of them entirely. Because really, we're looking for the lowest ratio that you can possibly have. So instead of Zn2S2, we just want Zns. It's the exact same thing, it's just less complicated. And this is more likely going to be what your compound is going to look like. So anytime you get a situation where the two numbers of your compound are exactly the same, or you've reached a point where you've gotten two numbers that actually are, that you can divide them to make them less, you should divide them and simplify them to their simplest form, okay? So now let's just go ahead and check. I can see that for zinc, I have 2 zincs, and each one has a charge of +2. This is from here, and I can see that I have 2 sulfurs, and each one of them has a charge of -2, which means this one is +2, this one is -2, and overall I have a charge of 0. So it all worked out perfectly. Okay, so there's one more thing I want to go over before we end this. It's simplifying your compound, okay? So listen, it's very important to simplify your compound because we are trying to find the simplest compound possible. So anytime you can, try to lower these numbers as much as you can using, correct math, okay? It's very easy when the two numbers are the same. You can just simplify them down to 1. But when you get an example like, let's say this one, C2H6Cl2. For me to simplify this, I can see that there is a clear common factor between the 3 of them. I can divide each one of them by 2, and I'll end up getting this, CH3Cl. Now I have my simplest form of this molecule, right? You're not always going to be able to do this. Like for example, the first 2 examples, we were not able to do this, but anytime you see an opportunity to simplify, you need to do that, okay? All right, so guys, today you're going to be doing a worksheet, so good luck. If you are confused, come back and watch this video. If you have any questions that the video did not answer, go ahead and message me on Shobi, and